So they want you to find box product of three vectors. Vector A is 1 I cap plus minus 2j cap plus 3k cap. So we have put lambda equal to what? 15, and we got 0. In board exam, if your lambda value is wrong, they don't give any marks. You know, if three vectors are coplanar, then their box product is 0. Welcome to the session, dear students. Today we'll go ahead with the problems of vectors. So the last exercise, that is supplementary reading they have given, but this is there in the syllabus. So find box product of A, B, C if vector A is I minus 2j plus 3k, vector B is 2i cap minus 3j cap plus k cap, and vector C is 3i cap plus j cap minus 2k cap. So they give three vectors and they want you to find what is called as box product. So dear students, box ABC means box product of ABC. Box product of ABC means determinant of, first row write the quotients of vector A. What are the quotients of vector A? 1, minus 2, 3. Then write the quotients of vector B. What are the quotients of vector B? 2, minus 3, 1. Then write the quotients of vector C. What are the vector C quotients? 3, 1, minus 2. So now expand this. So you know how to expand a determinant. In order to expand a determinant, you know the sign convention. First we should take plus, minus, plus. Expand 3 cross 3 determinant. 1 into delete the column and delete the row. Minus 3 into minus 2 is minus 6. Plus 6, minus 1. Minus of minus 2 becomes plus 2. Delete the column and row. We'll have minus 4, minus 3. Plus 3 into delete the column and row. 2 plus 3, 3 is 9. Simplify this. 6 minus 1 is 5. 5 into 1 is 5. Plus 2 into minus 7. Plus 3 into 11. Further simplification gives you the value, that is 5 plus 2 into minus 7 plus 3 into 11. So 5 into minus 14 plus 33. 33 plus 5 is 38. 38 minus 14. So that is 24. So that's the value of box product. So they want you to find box product of three vectors. Vector A is 1i cap plus minus 2j cap plus 3k cap, 1 minus 2, 3. Second vector 2 minus 3, 1. Third vector 3, 1 minus 2. Expand this. So 1 into delete the row and column, will get 6 minus 1. Delete the row and column, then it will become minus 4, minus 3. Then delete these two, will get 2 plus 9. Simplify this. So 6 minus 1 is 5, minus 7. And 9 plus 2, 11. Simplify, you will get the box product. Then show that the vector A is equal to I cap minus 2j cap plus 3k cap. Vector B is equal to minus 2i cap plus 3j cap minus 4k cap. Vector C is equal to, so vector C, they have given vector C is equal to, they want you to prove I cap minus 3j cap plus 5k cap. Three vectors are given, A, B, C. They want you to prove coplanar. All of you know the condition for coplanar. Three vectors are said to be coplanar if their box product is 0. So now we'll find the box product, and if it is 0, then they are coplanar. So we'll go for finding box product of A, B, C. What is the box product of A, B, C? So how to find box product? Determinant of, first row write the vector A quotients. What are vector A quotients? 1, minus 2 and 3. Then second row write the vector B quotients, minus 2, 3, minus 4. Third row write the vector C quotients, 1, minus 3, 5. Now expand this. So that is plus, minus, plus. 1 into delete the column, delete the row, 3 5s are 15, minus, minus into minus, 3 4s are 12. Minus of minus 2 becomes plus 2 into delete the column, delete the row, that is minus 10, plus 4. Then plus 3 into delete the column and row, that is 6 minus 3. Simplify this further. 1 into 12 minus 15 minus 3 is 12 is 3 plus 2 into minus 6 plus 3 into 3. Simplify this. We have 1 into 3 plus 2 into minus 6, then 3 into 3. So 3 1s are 3, minus 12, 3 3s are 9. So 9 plus 3, 12, minus 12, that is 0. So box ABC we have found out. So box ABC, box product of three vectors, vector A, B and C, we got 0. Therefore the given vectors, vector A, comma vector B and vector C are coplanar. So now you got the logic of coplanarity. When can you say the vectors are coplanar? Three vectors are said to be coplanar if their box product is 0. Find lambda such that the vectors I cap minus j cap plus k cap, 3i cap plus j cap plus 2k cap, and I cap plus lambda j cap minus 3k cap are coplanar. They give three vectors are coplanar. They want you to find the value of lambda. So let us assume there are three vectors. Let vector A is the first vector. What is the first vector given? I cap minus j cap plus k cap. And vector B is the second vector. What is the second vector given? 3i cap plus j cap plus 2k cap. And vector C, the third vector is I cap plus lambda j cap minus 3k cap. So three vectors are given. So they have given coplanar. So given vector A, comma B and C are coplanar. So all of you know, if three vectors are coplanar, indirectly they give box ABC is 0. This is given. They give box ABC is 0. So now we'll do box product of these three and we'll equate it to 0. So box A comma B comma C is 0 because they are coplanar. Means the given vectors are coplanar means the scalar triple product is 0. Scalar triple product means what? Determinant, first row, write the quotients of first vector 1 minus 1 1, and second vector, vector B quotients 3 1 2 3 1 2, and third row write the quotients 3 C vectors 1 lambda minus 3 1 lambda minus 3. Now expand this. You know how to expand 3 cross 3 determinant. So plus minus plus 1 plus 1 1 into delete the column, delete the row. 1 into minus 3 is minus 3, minus lambda into 2 is 2 lambda, minus of minus 1 into delete the column and delete the row. 3 into minus 3 is minus 9 minus 2, plus 1 into delete the column and delete the row. 3 into lambda is 3 lambda minus 1 is equal to what? 0. Now going ahead, 1 into minus 3 is minus 3, 1 into minus 2 lambda is minus 2 lambda, minus into minus plus 1 into minus plus 1 into 9 minus 9 minus 2 is minus 11, and plus 3 lambda minus 1 equal to 0. Further minus 3 minus 2 lambda minus 11 plus 3 lambda minus 1 equal to 0. Simplify this further. 3 lambda minus 2 lambda gives you lambda, and minus 11 minus 1 is minus 12, minus 12 minus 3, minus 1 minus 11 minus 12, minus 12 minus 3 is minus 15 is equal to 0. Our lambda value is exactly 15. You got the value of lambda as what? 15. So they want you to find the value of lambda. They gave coplanar. We got it. And if you want, you can do verification. Verification is not necessary. Just for the sake of our confirmation, we'll verify. Now we got lambda. So I'll take determinant of 1 minus 1 1, and second row 3 1 2. Just I'm verifying. So I am repeating, verification is not necessary. So it should give 0. 1 into delete this minus 3, 15 2s are 30, minus of minus 1 is plus 1, delete this, it will become minus 9, minus 2 plus 1 into delete this, 15 3s are 45 minus 1. Simplify this, so it will become 1 minus 33 plus 1 into minus 11 plus 1 into 40. So delete this, so 1 into, if you delete this, 45 minus 1 is 44, that is minus 33 minus 11 plus 44. So 44 minus 44 plus 44 is exactly 0. So whatever we assumed, so what we have done, in the place of lambda we assumed, so we have put lambda equal to what? 15, and we got 0. So therefore whatever the answer we got here, what is the answer we got? Lambda. So therefore lambda is equal to what? 15 is the right answer. So dear students, I have done verification, not required. Just why I told you to verify, if time permits, verify. Why? Because in board exam, if your lambda value is wrong, they don't give any marks. Exactly, you should get 15 in this problem. So any problem when they give, you will solve and you will get lambda. Spend 2 minutes. So put the lambda in the place of lambda. So here in the place of lambda, put 15 and expand. It should give RHS, that is 0. Then you are right. Now next, question number 4. Vector A, I cap plus j cap plus k cap. Vector B, I cap. Vector C, C1 I cap, C2 j cap, C3 k cap. Then C1 is equal to 1 and C2 is equal to 2. Find C3 if they are coplanar. Question A will solve. So now part A will solve. So vector A is given. What is vector A given? I, j, k. I cap plus j cap plus k cap. Vector B they gave. What is vector B they gave? Vector B is just I cap. Only I cap is given. Vector C they gave. Vector C they gave C1 I cap, C2 j cap, C3 k cap. C1 I cap, C2 j cap, C3 k cap. And the question is, they also mentioned C1, C2 they gave 1 and 2. They want C3. So C1 is equal to 1 and C2 equal to 2. So I'll substitute them. So vector C is what? 1 I cap plus 2 j cap plus C3 k cap. So now you know vector A, you know vector B, you know vector C. So you know vector A they gave, you know vector B they gave, vector C they gave. Now they wanted to find C3, they gave coplanar. What is meant by coplanar? You know, if 3 vectors are coplanar, then their box product is 0. So they have given box A, B, C 0 because they told coplanar. So box A, B, C, if coplanar, so they told ABC, the word coplanar is given. 3 vectors are said to be coplanar if their box product is 0. Means indirectly they give this. How to find box product? Determinant of first row, write vector A quotients. What are vector A quotients? Quotient of I, j, k. 1i, 1j, 1k. So 1, 1, 1. Vector B quotients, only I is there. So only I quotient is 1, j, k, 0, 0. And they gave C1, C2 value. So 1i, 2j. 1, 2 and C3 is unknown, we will write C3 only, is equated to 0. Now we expand it, you will get the unknown called C3. So now how to expand? Plus, minus, plus. Delete the column, delete the row, 1 into. When I delete the row and delete the column, I will get 0 minus 0. Minus 1 into. Delete the column, delete the row. C3, 1s are C3, minus 0. And plus 1 into. Delete the column, delete the row, 2 minus 0. Is equal to what? 0. So now 0 minus 0 is 0, 1 zeros are 0, minus C3 plus 2 is equal to what? 0. Or C3 is equal to minus C3 is C2, C3 is what? 2. Transfer that side, so this implies minus C3 is equal to minus 2 or minus minus cancel, C3 is 2. So for the first value, we got C3 value, they want you to find what? C2, find C3 they told. So we got C3. What is C3 we got? Exactly 2. And the second part, C1 minus 1, C2 1, show that no value of C1 makes coplanar. So if you take C1, any value it will not make, they are asking you. So now we will go to the next part B. Part B, vector A is same, vector B is same, vector C, they gave C1, C2 value is different. Vector A is what? 1, 1, 1, 1 I cap, 1 j cap, 1 k cap, and vector B is what? I cap, vector C is what? Vector C is that is C1 I cap, C2 j cap, C3 k cap. C1 I cap, C2 j cap, C3 k cap. C1 is not given. C1 let it be C1 I cap. C2 they gave. C2 is minus 1 j cap. C3 they gave, that is 1 k cap. So now vector C, they told coplanar. Coplanar, all of you know coplanar means what? The box product is 0. They gave box product is 0. So let us take box ABC equal to 0. Box ABC will take it as 0. All of you know box product means what? Determinant. First row 1, 1, 1. Second row 1, 0, 0. Third row C1 minus 1, 1. Equated to 0. Now expand this. Plus, minus, plus. 1 into. Delete the column, delete the row. So we'll get 0 minus 0. Minus 1 into. Delete the column, delete the row, we'll get 1 minus 0 plus 1 into, delete the column, delete the row, minus 1 minus 0. Dear students, it is interesting here we don't get C1 value only. This is 0 and this will become minus 1. This will become plus 1. This is 0. So we get 0 only. So here C1 place any value. So that's what we say. So no value of C1. So no value of C1, hence the proof. There is no particular value of C1. In the place of C1, you put anything, it will become coplanar only. So we say no value of C1 makes ABC coplanar. Because C is vanished. In this expansion, C goes off. We don't have C only. So that's the reason. Next, show that the 4 points with position vectors 4 I cap, 8 j cap, 12 k cap, 2 I cap, 4 j cap, 6 k cap, 3 I cap, 5 j cap, 4 k cap, and 5 I cap, 8 j cap, 5 k cap are coplanar. So 4 points they give position vectors they give. In my last class I taught you, whenever they give position vectors, create co-initial vectors. After you create co-initial vectors, you do the box product. When you do the box product, it should give you what? 0. They have given position vectors and we need to prove box product. So first write what is given. What is given? They have given vector OA, position vector of point A. OA is what? 4i cap, 8j cap, 12k cap. And they give OB, position vector of second point, OB is what? 2i cap plus 4j cap plus 6k cap. So OC, position vector of third point, OC. So let us assume ABC at the point. So then 3i cap plus 5j cap plus 4k cap. Then they give OD, position vector of D. What is position vector of D? OD, that is 5i cap plus 8j cap plus 5k cap. So we got OA, OB, OC, OD are given. From this create co-initial vectors. What are co-initial vectors? AB, vector AB. Vector AB means what? OB minus OA. OB minus OA if you do, you'll get AB, that is B minus A. Subtract. So 2i minus 4i is minus 2i cap. 4j minus 8j is minus 4j cap. And 6j minus 12j is minus 6k cap. Now this is vector AB. Now we go to vector AC. AC means what? Formula is OC minus OA. C minus A. That is third vector minus first vector. 3 minus 4 I cap is minus I cap. And 5 minus 8 is minus 3 j cap. And 4 minus 12 is minus 8 k cap. And yes, AD. What is vector AD? OD minus OA. Vector OD minus OA. So D minus A you do. That is 5 minus 4 is 1 I cap. 8 minus 8 is 0 j cap. 5 minus 12 is minus 7 k cap. So now you got AB, AC and AD. So we'll find box product of AB, AC, AD, co-initial vectors. You can see all the vectors are having same initial point. All of you know how to find box product. Box product means determinant of first row. Write the quotients of AB. What are the quotients of AB? Minus 2, minus 4, minus 6. So minus 2, minus 4, minus 6. And then write the quotients of AC. Minus 1, minus 3, minus 8. Minus 1, minus 3, minus 8. Then write the quotients of AD. 1, 0, minus 7. 1, 0, minus 7. Now expand this, plus, minus, minus 2 into delete the column, delete the row, plus 21, it will become minus 0. Minus of minus 4 is plus 4, delete the column, delete the row, it will become 7. Minus of minus 8 plus 8, minus 6 into delete the column, delete the row, 0 plus 3. Now minus 2 into 21 plus 4 into 8 plus 7, 15. Minus 6 into 3, 21 minus 42 plus 15 into 4, 60 minus 18. So minus 42 plus 60 minus positive 18, 18 minus 18 is what? 0. So therefore the given vectors, so here 4 vectors, what do they give? Forms position vectors forms what is called as coplanar points. Therefore the given vectors, position vectors are the position vectors of coplanar points. Coplanar points, or we can also say the given position vectors forms the coplanar points because box product is 0. It's one of the good questions. In spite of giving point, in spite of giving vector, they give position vector. Position vector means what? Vector drawn from origin. So suppose this is position vector of A, this is position vector of B, and this is position vector of C, and this is position vector of D. So we call them as OA, OB, OC, OD. Then create co-initial vectors. Co-initial vector means their initial point should be same. AB, AC, AD. So AB starts with A, AC starts with A, AD starts with A. So create co-initial vectors. So after you create co-initial vector, do box product. So box AB, AC, AD, expand it, you will get 0. So if box product of 3 vectors is 0, then the 3 vectors are 0. And the 3 vectors are formed by 4 points. So therefore the given points are also what? Coplanar. So this is a conclusion. I hope all of you understood. This is one of the important questions. In my last class I gave points, but they gave position vectors. So from position vectors, create co-initial vectors and find the box product of co-initial vectors. If you get 0, then we say they are coplanar. So I hope all of you understood this. Now find x such that the 4 points are coplanar. So they wanted to find x. They told 4 points are coplanar. From the points, create co-initial vectors. So they give points. So from that I'll write OA. OA means what? Position vector of A. For the point, put ijk. So 3i cap plus 2j cap plus k cap. And OB means position vector of second point. What is second point? 4x5. 4i cap plus xj cap plus 5k cap. Then OC. OC means position vector of third point. For C, you put ijk. 4i cap plus 2j cap minus 2k cap. And then OD. OD means position vector of point D. That is 6i cap plus 5j cap minus k cap. Dear students, if they give point, for the point if you put ijk, they will become position vectors. Now we have OA, OB, OC, OD. First create AB. What is AB? Position vector of, AB is what? Vector AB is what? OB minus OA. All of you know any vector can be written in terms of position vector. So position vector means what? Vector drawn from origin. OB minus OA means B minus A. If you do that, you will get 4 minus 3, 1i cap, x minus 2, j cap, and then 5 minus 1, 4k cap. So this is vector AB. Then go to vector AC. AC is what? OC minus OA. So OC minus OA means C minus A. So subtract, that is 4 minus 3 is I cap. Then 2 minus 2 is 0 J cap. Then minus 2 minus 1 is minus 3 K cap. Then AD. What is vector AD? OD minus OA. Vector OD minus vector OA. So that is 6 minus 3 is 3I cap. Further 5 minus 2 is 3J cap. Then further minus 1 is minus 2K cap. Vector AB, AC, AD. They told they are coplanar. So means given, if 3 vectors are coplanar, when can you say coplanar? Box AB, AC, AD is what? 0. Because they are coplanar. All of you know if 3 vectors are coplanar, then their box product is 0. So now, what is AB? 1x minus 2, 4. 1x minus 2, 4. Quotients of AC. What are the quotients of AC? 1, 0, minus 3. 1, 0, minus 3. Vector AD, 3, 3, minus 2. 3, 3, minus 2 is equal to what? 0. So now plus, minus, plus. 1 into, delete the column, delete the row, 0, minus of minus plus 9. Minus x minus 2 into, delete the column, delete the row, minus 2 plus 9. Plus 4 into, delete the column, delete the row, 3 minus 0 is equal to what? 0. Now further 9 it is minus x minus 2 into 7 it is plus 4 into 3, 12 is equal to what? 0. Simplify further. 9 minus 7x plus 14 plus 12 equal to 0. That is, simplify, minus 7x, 14 plus 12, 26, 26 plus 9, 35 plus 35 is equal to 0, or minus 7x is equal to minus 35, or x is equal to minus 35 by minus 7. Minus minus cancels, x is 7 ones are 7 5s are. You got the value of x. What is the value of x? 5. And they gave 4 points and they told they are coplanar. If the points are coplanar, then co-initial vectors with same initial point A, should also give you 3 vectors with coplanarity. So we took box ABC, box AB, AC, AD equal to 0 and we solved and we got 5. Most important problem, the same problem has been repeated twice or more than twice in your board papers. Okay, now we'll go to the 7th problem. Show that the vectors ABC are coplanar. They wanted to prove these 3 are coplanar, comma, A plus B, B plus C, C plus A are coplanar. They gave 3 vectors are coplanar. See, first we'll write given. What is given? Given A plus B, comma B plus C, comma C plus A are coplanar. means that is they gave box A plus B, comma B plus C, comma C plus A. Coplanar means what? This is 0. This is given. And to prove, what we need to prove? They wanted to prove A, B, C are coplanar. They wanted to prove box A, B, and C are coplanar. How can you prove 3 vectors are coplanar? Means you have to prove box A, B, C is coplanar. Means to prove box A, B, C is equal to what? 0. So now simple, we'll take, consider box A plus B, comma B plus C, comma C plus A. All of you know very well, C plus A. All of you know box A plus B, B plus C, C plus A can be written as A plus B dot, first vector dot, second vector cross, that is B plus C cross, C plus A. All of you know, box, consider A plus B, vector A plus vector B, comma, vector B plus vector C, comma, vector C plus vector A box product. You know box product can be written as scalar triple product. I can write box A plus B, comma, B plus C, C plus A as A plus B dot, B plus C cross, C plus A. Now we'll simplify this. Vector A plus vector B dot B cross C plus B cross A plus C cross C plus C cross A. Now further we'll simplify this, we'll expand. So vector A plus vector A dot B cross C plus vector A dot B cross A plus vector A dot C cross C plus vector A dot C cross A. Now I have done dot product of A, I have done with A dot B cross C, A dot B cross A dot C cross C, A dot C cross A. Now we will go with B, B dot this, like that. So B dot B cross C plus B dot B cross C, then B dot second term B cross A, then B dot third term B dot C cross C, then B dot C cross A. So now we'll compress the result. All of you know A dot B cross C can be written as box ABC, and in scalar triple product, if any one vector repeats, answer is 0. Here A repeated, so 0. Here here C repeated, 0. Here A repeated, 0. Here again B repeated, 0, and B repeated here. In scalar triple product, in combination of 3, any one vector, if it repeats, answer is 0. So here B, C is repeated, 0. Here last one is B, C, A. So I can write box B, C, A. You know, in the properties I taught you, scalar triple product is cyclic. Box ABC is same as box BCA. So now finally, I can write first term is ABC and all other terms are 0. I will leave them. Plus I am left with BCA. BCA is in order. When you start with B, BCA, cyclic. ABC is same as BCA is same as CAB. So instead of BCA, I will write ABC. So I will get ABC, comma ABC. ABC plus ABC. What is ABC plus ABC? 2ABC. But when you read the given question, so I got 2ABC when I expanded this. I want to prove this is coplanar. If I want to prove A plus B, B plus C, C plus A coplanar, I want to prove this is 0. But I got this as 2ABC. But when you read the question, they told ABC are coplanar. They told ABC are coplanar. Sorry, show that the vector ABC. So we need to prove they are coplanar. So dear students, now we got this. Call it as equation 1. So therefore, they told ABC we need to prove coplanar. So given, so what is given? A plus B, B plus C, C plus A is 0. This is given. So this is 0. So this is 0. I'll go on equating to 0, or this is equal to 0. Instead of calling it as 1, A plus B, B plus C, C plus A is 0. When I went on solving, I got this 2ABC. 2ABC is what? 0. So if 2ABC is 0, so dear students, we got 2ABC is equal to 0. That implies ABC is also 0, and therefore ABC are coplanar. Box A plus B, B plus C, C plus A is 0 because they told coplanar. When I expand LHS, I got 2 ABC. 2 box ABC is 0 means box ABC is 0. Box ABC is 0 means ABC box product is 0 means they are coplanar. Hence the proof. So by this I am concluding scalar triple product. So I'll see you in my next session. Thanks for attending. Thank you.